Deep beneath the Earth's surface, there's this thick, dark liquid, crude oil. And honestly, in its raw form, it's pretty much useless. But through this incredible process of transformation, it literally becomes the foundation of our modern world. So, how does this alchemy actually work? Let's get into it.
I mean, really think about it. How do we get from that thick black goo to the fuel that powers your car, or even the plastic case on your phone? Well, the answer is this fascinating mix of some pretty clever chemistry and just massive scale engineering.
The difference is just staggering. On one hand, you've got the raw material, basically ancient, decomposed organic stuff, and on the other, you have these highly engineered products that do everything from fueling our cars to building our homes and even saving our lives. The journey between those two states is just incredible.
So, to unlock all that amazing potential, crude oil has to go on a journey, and its very first stop is a place where the real magic happens. Welcome to the oil refinery. You got to picture this place as a massive, sprawling city made of steel. It is this unbelievably intricate labyrinth of pipes, towers, and furnaces, all working together perfectly. This is the front door, where that raw sludge starts its transformation into something truly powerful.
Okay, so what in the world actually happens inside this city of steel? Well, it all comes down to a really clever bit of science that lets us separate the crude oil into all its different valuable parts.
The main process is called fractional distillation. Now that sounds super complex, I know, but the idea behind it is actually pretty simple. See, crude oil isn't just one thing. It's a mix of thousands of different molecules. And the key is, each of these molecules has a different size, which means it has a different boiling point. And that right there, that's the property we exploit to pull them all apart.
It all happens in 3 basic stages. First, the crude oil gets superheated in a furnace, turning the whole thing into a hot vapor. Then, that vapor gets piped into the bottom of a huge steel tower. As it rises up, it starts to cool. And this is where the magic of separation really begins.
Let's start our journey at the very bottom of the tower. Down here, where it is scorching hot, we're talking over 350 degrees Celsius, only the biggest, heaviest molecules turn back into a liquid. This thick, gunky residue is called bitumen, which you probably know better as the asphalt used to pave our roads.
Now, as we move up a bit into the slightly cooler middle section, we start finding molecules that are a little smaller, a little lighter. This is where we get essential stuff like diesel for all the trucks and trains, and also the lubricating oils that keep all that heavy machinery running without grinding to a halt.
And we keep going up, where the temperature drops even more. The molecules condensing out here are lighter still. This is the sweet spot for things like kerosene and, crucially, the high-octane jet fuel that powers the entire global aviation industry.
We're getting near the very top of the column now, where it's much cooler. And here, some of the lightest, most volatile liquids finally condense. And this, of course, is gasoline, the fuel that powers most of our cars.
Finally, right at the very peak of the tower, there are some molecules that are so light they stay as a gas even at the coolest temperatures. These are captured and become what we know as liquefied petroleum gas, or LPG, which a lot of us use for heating and for cooking on the grill.
But believe it or not, the story doesn't stop with fuel. Some of those fractions from the tower, they go on to have a whole second life, becoming the hidden building blocks of pretty much everything around us.
And that brings us to the world of petrochemicals. Through a process called cracking, scientists use intense heat and catalysts to literally break down long, heavy hydrocarbon chains into smaller, way more versatile molecules. And these little molecules are the fundamental Legos for an absolutely astonishing number of materials.
So what do we build with them? Oh, well, pretty much everything. We're talking about all the plastics in the world, from water bottles to car bumpers, synthetic rubber for tires, fertilizers that help feed the planet, and even critical components for countless life-saving medicines.
Just think about your day so far. These materials are in the toothbrush you used this morning, the polyester shirt you might be wearing right now, the case that's protecting your phone, and the sterile medical syringes that are absolutely essential to modern healthcare. They are truly everywhere.
You know, when you take a step back and you look at this entire process, from deep underground all the way to the products in our hands, it's really a story about human ingenuity. For more than a century, our ability to figure this out, to harness and transform this resource, has built our cities and connected the entire globe. It's a really powerful testament to our own cleverness. But as we keep innovating, that story is now turning to a brand new chapter. And this leads us to what is maybe the most critical question of our time. That same human ingenuity that unlocked the incredible power of oil is now being called upon for its next great challenge. How do we transition from the very energy systems that built our modern world to the sustainable ones that are going to power our future?